In this video, we are examining what determines the lambda max of the emission spectra. Lambda max is the maximum wavelength of emission, meaning the wavelength at which the most photons are emitted by the substance. The hypothesis we had to test was that lambda max is determined by the observed color of the substance. In glow sticks, the lambda max for emission represents the color of the glow stick. So if a glow stick had a maximum emission wavelength in the green wavelength range, it would be absorbing the least amount of wavelengths of green light and more wavelengths of other colors. In our lab, we used emission spectroscopy to analyze the potential dependency of lambda max on color through the dye from a red and a green glow stick. Energy is required for electrons to move to higher energy levels. This often occurs through absorption of photons, which are quantized packets of energy that electrons can absorb that excite them from the ground state to higher energy levels. On the other hand, energy is emitted when electrons fall from the excited state back to their ground state. This energy is also released as photons. As seen here, the electrons in the green glow stick are being excited to a higher energy level than the electrons in the red glow stick, which means the electrons of the green glow stick absorb photons of higher energy than those of the red glow stick. This is probably due to the structures of the different colored substances, but this also means that the wavelength of the electrons of the green glow stick must be shorter, as shorter wavelength is associated with higher energy for photons.
The information provided supports our data because, as we can see, the lambda max of green is lower, so it has a higher energy. In a similar fashion, the lambda max of red is higher, so it has a lower energy. Even though we mixed the red and green dyes, the lambda max did not change, even though the color of the dye changed to orange. This information tells us that we have separate emission peaks for each color. Even though the color visibly changed when the red and green dyes were mixed, the composition of the red and green dyes did not. So the lambda max should and did remain the same.
Another way to explain the quantization of energy is by comparing it to the consumption of energy drinks. If you were to drink one energy drink, it would contain a certain dosage of caffeine that would put your body into an excited state. As the caffeine wears off, your body's energy level returns to the original resting state, or similarly, the ground state. You might have to drink more energy drinks at one time to have enough energy to release to accomplish certain tasks, just like it takes a specific amount of energy to emit different colors of light. For instance, it might take you 3 energy drinks to have enough energy to release to run a mile, but only 1 for you to get out of bed, just like how it takes around a 500 nanometer wavelength to emit green photons, but around a 700 nanometer wavelength to emit red photons.